Okay, hi everybody. So today I'm gonna be showing you how to solve trig equations. So let's start off with question 1. So let's say that you have 2 cosine of 3 of x is equal to negative root of 3. So basically what you want to do first is you want to isolate the trig function. So you're gonna have cosine of 3 of x is gonna be equal to negative root 3 over 2. So now you want to solve for the inside angle. Okay, so first you isolate, I'm just going to write this for the first time that we do this, so that you're going to isolate the function, and now you're going to solve for inside angle 3 of x. Okay, so now what you're going to do is you're going to have cosine theta is going to be equal to negative root 3 over 2. So you're going to have theta is equal to 5 pi over 6 and 7 pi over 6. And this is going to be in 0 to 2 pi. And now, so you're going to have, from this, you're going to have 3 of x is equal to, you're going to write the pattern for each of these. And you're going to remember that, like, the pattern for this is going to repeat at 2 pi, every 2 pi k. So basically, essentially, what you're going to do is, like, you're going to think of this, like, on the unit circle. Like, where is 5 pi over 6? And where is 7 pi over 6? So, like, basically, like, on the unit circle, like, we know that, what is it? We know that, like, sorry, my name is glitching. You know that 5 pi over 6 is going to be over here. And we know that, what is it? So, and then we know that, our second solution is going to be 7 pi over 6. And we know that 7 pi over 6 is going to be over here, which is, like, slightly below. So basically, like, you only have to, like, you only list solution once in 0 to 2 pi. So then after that, it repeats every 2 pi k for k is a part of z. And yeah, so basically repeats, and you had to, like, listen once, and then, like, after you listen once, then you just, like, that's a general pattern. And then this is the case for sine x, cosine x, what else, cosecant x, and secant x. And for other things it's different. I mean, for cotangent and tangent x is different, but we're gonna get there. Okay, so now we're also gonna do this 3x, or okay, hold on, I'm just gonna, like, write it like this so that you can, like, see they're, like, side by side. Or 3 of x is equal to 7 pi over 6 plus 2 pi k. And oops, okay, that's divided by 6. Okay, so now we're gonna divide by 3. So dividing everything by 3, we get x is equal to 5 pi over 18 plus 2 pi k over 3. Or we get that x is equal to 7 pi over 18 plus 2 pi k over 3. Okay, 3. So, and if you don't understand how we got that, we just, like, divided everything by 3 like that, and then we divide everything by 3 like that. And then after that, yeah, that's how we get that. And yeah, now we can list all solutions. Yeah, so for all solutions that are specifically in 0 to x to 2 pi, well, we can use k is equal to integers of 0, 1, 2, and this is because since 2 pi over 3, you can do that 3 times max in 2 pi reaches in. Okay, so basically now we can, like, okay, I'm gonna move this work over here. Yeah, Okay, actually, like, I'm gonna just write that over there because I want this to be like neat so that you can see it in the end. Okay, so we can list with the k-ins. So I'm just gonna do this for the first one. K is equal to 0. That would be 5 pi over 18. And then k is equal to 1. That's gonna be 5 pi over 18 plus 12 pi over 18 is just gonna be 17 pi over 18. Now for k equals 2, you're gonna do that 2k is equal to 3. Oh, okay, actually, yeah, no, it's not k equals 2, 3. So it's k equals 2. That's only 2 times max. So you're gonna have why is that under racing? Okay, that's actually like, okay, whatever. Now you're gonna add from 5 pi over 18, you're gonna add again, just gonna add like the next equivalent. So it's gonna be 24 pi over 12. So basically you just like double it and give it to the next person. Double the numerator, double this, like double, you just like basically you times 12 did, and then you just times 2 did. So then it's like, now it's gonna be 29 pi over 18. Oh my gosh, wow, that's awesome. Now we're gonna do the next side. Okay, oops, k is equal to 0, k is equal to 1, and then k is equal to 2. So basically how we're gonna do this, that's just gonna be starting off with 17 pi over 18, and then you get 19. Okay, why does that look weird? 19 pi over 18, and then after that you get 31 pi over 18. So now we can write all of the solutions. What are all of the solutions? So this is going to be like x is equal to 5 pi over 18. Well, earlier we just had the general solution. Okay, wait, let me actually like write that there so you like know. These are these are general. Okay, this is solutions in here. No, we're just gonna write that. X, okay, wait, no, let's move this down a little bit. Okay, x is 5 pi, 7 pi over 18. Awesome. 19 pi over 18. 29 pi over 18. 31 pi over 18. Now all this, we can box that up. Hooray. Now after this, we're gonna do our next problem. So what we're gonna do is like, we're gonna do let me just grab this. Okay, sorry about that. Okay, we're gonna do question 2. So for question 2, how we're gonna do this is we have sine squared of x plus sine of x minus 2 is equal to 0. So now we're gonna do like let u equal to sine of x. So now we're gonna have u squared plus u minus 2 is equal to 0. Now you're gonna factor that to u plus 2. U minus 1 is equal to 0. And then now you have u is equal to negative 2, or u is equal to 1. Now you can convert this back. Sine of x is equal to negative 2, but there's gonna be no solution. And the reason why is because sine x range is from negative 1 to 1. So now for u equals 1, okay, great. So that's just going to be x is equal to pi over 2 on the range. Range is 0 to 2 pi. Okay, I mean on, what is, that's not, yeah, just like on the interval. Yeah, so x equals pi over 2 is just the only solution. So you can just box that. Now let's move on to our next question. Let's say we have 4 cosine squared of 2 of x is equal to 1. So like that's going to be equal to cosine 2 of x squared equals 1 over 4. So now you're going to take the root of that. That's going to be cosine of, cosine 2 of x is equal to plus or minus 1/2. And now after this, we're gonna solve for 2 of x in the interval of 0 to 2 pi. So basically for cosine of theta, equals to 1/2, you're gonna have theta is equal to, okay, no, you're gonna have theta is equal to pi over 3, and also 5 pi over 3, which is essentially just 5 times 30, which is just 150 degrees. And then you're gonna have cosine of theta is equal to negative 1/2, and this occurs at theta is equal to 2 pi over 3, and also at 4 pi over 3. So that's going to be pi divided by 3 is 60. That's 120 degrees. And then 4 pi over 3. Wait, we can actually draw that out so you can, like, see. Okay, pi over 3 is about here. So it's, like, 60 degrees. And then 5 pi over 3 is about, like, over here. Okay, that's, like, weird. 5 pi over, wait, pi over 3 is 6. Okay, sorry, I meant to say that's actually 300. I don't know why I said that. And then 2, okay, pi over 3, that's just 60 times 2. So that would look like right here, 120 degrees. And then 4 pi over 3, pi over 3 is just 60 times 4 is 240. That would be like right here, as you know, and then that's just gonna cycle. So now we know that 2 of x is gonna equal to pi over 3, 2 pi over 3, okay, whoa, 4 pi over 3, oops, 5 pi over 3, and now dividing everything by 2, now we have that x is equal to pi, okay, stop, x is equal to pi over 6, pi over 3, 2 pi over 3, 5 pi over 6. But now, okay, we must include all solutions with 2 of x through 0 is less than 2 of x for pi, because x is going to be of 0 to 2 pi, okay? So add 2 pi solutions. Now 2 of x is equal to pi over 3 plus 2 pi, 2 pi over 3, okay, we can basically, like, just do like this. Now, after this, we can divide everything by 2. This becomes x is equal to pi over 6 plus pi over 3 plus pi, 2 pi over 3 plus pi over 6 plus pi, okay, oops. So that means that you get x is equal to 7 pi over 6 over 3. So this is gonna be, so you have these and you have these. Now that's all gonna be like, you're gonna have this. Okay, actually, like, what? This looks weird. Now these are gonna be, all your solutions are gonna be here. This is the added, like, you're gonna add those ones to your original that we just found, 5 pi over 6. Now we're gonna add all these, like, Hooray, that's it. Okay, now we're gonna do this problem. So we're gonna take the square root. It's gonna be sine of 4x is gonna equal to 1 over root 2. But we can rationalize this. So that's gonna be equal to plus or minus root 2 over 2. Okay, great. So now, I'm gonna do sine of 4x is equal to negative root 2 over 2. Sine of x is 4x is equal to positive root 2 over 2. Now, where this occurs is gonna be, okay, now we're actually just gonna pretend, okay, we're gonna solve for 4x. Now, like, we're actually gonna do sine of theta is equal to, like, this. So then just, like, imagine it again, like, it's just, like, temporarily, like, sine of theta is equal to positive root 2 over 2. It's gonna be, like, theta is equal to, pi over 4. It's just easier to visualize this way. 3 pi over 4, and you can draw that out if you want. It's gonna be 45, and then 3 pi over 4. 3 pi over 4 is just pi over 4, 45. That's gonna be 135, and then here it's gonna be 5 pi over 4, 7 pi over 4, so 7 pi over 4. Okay, oh my goodness, 5 pi over 4, that is just gonna be pi over 45 degrees times 5, that's gonna be like 225 degrees, I'm pretty sure. And then here is 75 pi over 4 is just 45 times 7, that's gonna be like 315 degrees. And yeah, so now, okay, now we can rewrite these solutions as 4 of x over pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, plus 2 pi k. Awesome. Now we can divide everything by 2. Oh my goodness, yes. Now we just have x is going to be equal to pi over 16, 3 pi over 16, 5 pi over 16, 7 pi over 16 plus pi k over 2. So now we're gonna list all solutions in zeros less than x to pi. So now, like, because period step is pi over 2, use like k is equal to 0, 1, 2, 3. So this gives us, therefore we get 4 blocks of 4 base solutions. So essentially you get, for our base set, we get like pi over 16, 3 pi over 16, which is what we already had, and 5 pi over 16, 7 pi over 16. Now we can like add pi over 2, which is equal to 8 pi over 16 common denominator, then to each of them, then you, basically to each of them, like, you just get like 9 pi over 16, 11 pi over 16, 13 pi over 16, and then 15 pi over 16, and then now we can add pi, which is equal to 16 pi over 16 to each of them. Now if you add this to each of them, like, let me actually like do it like right here, and then that's gonna adding that to each of them, if we put all the solutions together, it's gonna be really long.